get started with the control planning session. So this is one of the one or two of the Kubeflow projects. And we're talking about control plane is basically to deploy and to manage the monitor the Kubeflow, right? And so if you it's I think Animesh was just saying that he want to point to the link of the document. So here is the link to the Kubeflow document. And the first thing here, of course, is that when you get started, how do you install the Kubeflow and so on. And you can follow all this link for different scenarios, right? So you can say I only have a single node cluster, I can do a single node deployment, or if I just want to explore and tear down, you can, or you want to just use the cloud deployment and so on. All the different scenarios, all various environments that you can try, like the GCP, AWS, IKS, OpenShift, whatever. There's in that document, there's all the link that you can go, right? So you install that on the Kubeflow on AWS, on Azure, GCP, or IBM Cloud, OpenShift. There's all a link for there. And if you have a problem, finding the documents issues, right? And you can open the issues there, and we'll talk about how to do the pull request, the open issue, and so on in tomorrow's hands-on session on that. So as I just say that you can run on KS, you can run on Prime Linux and Mac OS Windows, and also run on Minikube. And there's also a Minikf that is provided through the Kubeflow org, right? And it's basically running Kubeflow on a Minikube, and it's just doing all the provision of the Minikube and so on in a single step, for a single command for you, which is flexible, right? But it depends on whether it just to give you some sense about what a Kubeflow is. Kubeflow deployment can deploy through the command line or operator. So the command line is basically the what a Kubeflow project is about. When you deploy a command line in or Kubeflow operator, you need to provide some of configuration for what kind of applications that or component you want to install with Kubeflow. So basically, Kubeflow is provide something like a framework for you. And on that framework, you can or infrastructure framework, right? So on top of on that, what you want to run, the application or the components that you want to run is all configurable, right? So you can say, I want to run pipelines. I also want to run the model serving. So you can put the pipelines and KF serving, for example, these two components in it. And if you don't care about the you don't care about the security, you don't need the to do the DAG or certificate or cert management and so on. You don't need to install those application and so on. So that is basically provided through the configuration. And the configuration, all those configuration right now, Kubeflow has a repository called manifest, right, to store all the different configuration for different setup. And we have for IBMs, we have the IBM running on IKS, some because we need to do some specific configuration, and so we put some of the specific configuration in the stacks under the IBM. So for the basically some specific configuration we need for the IBM IKS to run and to work with the Kubeflow. And you can also create your own kind of configuration, right? So as I said, there's two repos mainly for the control plane. One is the Kubeflow and the other is manifest. And we'll go through both of these, right? So we talk about the Kubeflow first. So Kubeflow basically is the control plane for the deploying and managing Kubeflow. So you can run Kubeflow as a command line, and with the Kubeflow configurations for different Kubernetes flavors and different configuration of the applications, right? Also, in this Kubeflow Kubeflow repo, we also IBM, right? We also introduced the Kubeflow operator that it's easy to deploy and also monitor the Kubeflow after it's deployed. So we'll go through about the source code about it. this Kubeflow operator. It basically the README is here. We have a design doc about why we're using it, and the Kubeflow operator is built on top of the operator framework. So we'll talk about that more also later. So one of the things that keep popping up is the KFDAP configurations. So KFDAP configuration basically is the manifests that specifies a set of applications. And these applications, like all their resource files, is another set of manifests in a YAML format. Those those set of manifests can be customized, or you can provide some of base configuration, and then you can also apply some of the some of the other configuration values or something just for your organization or for your department, and that is through the customize. This is another project under the Kubernetes main six projects, and this customize basically is used to customize raw and template-free YAML files, right? For it's kind of like the an editor or something like that. It can do the pass, and you can, and then later on you can just stitch together and generate the resource YAML file that Kubernetes understands, and then you can just use put all those files, resources file to the Kubernetes and run it to create all those resources. So that's what basically the customize is means, right? So the KFDAP configuration is contains all the resources of each application, right? And
I
all
just
the
wanted
layouts
to
for the
say, could you speak just a little bit more slowly? Is that okay?
Okay. So
Thank you.
so the KFDAP is contains all the resources for each applications, and these applications are also organized in the layout for just I was talking about is the customer is able to process, and so all these things are saved under the Kubeflow manifest repo for this collection of the KFDAP configurations, and we are just seeing it. So if you need to I mean, if you want to contribute to Kubeflows, and at least for the control plane, definitely you want to get knowledge or familiar with the customize this project. And as I was just showing here, go to here to understand what customize is and try a little bit on it. So as I say, it's basically to generate the final kind of resource YAML file for Kubernetes to understand, so that you can apply, you can create, and so on. So the things that you can look into is very simple. It just contain a generator, a transformers, and also there's a resources for the customers to do all the customization. Right? So the generators is basically you can generate some of the configuration config maps based on some of parameters you pass in, and also can generate some of secrets, right? So because of you can generate, that means that you can customize, right? So you can provide different of the files or environment files that for the generators to generate for different scenarios. And transformers, that for example, you can change the image. So for one organization may want to have a build a customized Docker container image for a deployment and so on. Resources are all the resources that is going to be touched by the customer. And yeah, so this is talk about what a Kube cutter is about. So KFDAP configuration, will go a little bit deep into it. This is the one of a KFDAP configuration looks like, right? So it has the KFDAP, have an API version, have a kind, and it defined as a KFDAP. And this is all defined in the KFCutter projects under the APIs. So you can see all the KFDAP definition, KFDAP spec, what's the application looks like, what is the customized config, has all these fields, right, repo reference, overlays, and parameters. You have a define here, I will define two applications, application 1 and application 2. And for application 1, you can change, you can pass in some of the parameters And for application 2, you can also specify some overlays, which is based on top of the basic of the resource definitions, and you can have your own or your kind of the application layer on top of it. Right? And the directory structure of it is something like this. On the manifest, you can see there's application 1, there's a base. In application 2, there's a base, and there's also overlays of the application. Inside application, you have application.yaml. Of course, you can see there's always a customization file for each of the this directory. Either it's a base or it's an overlay. This customization YAML file basically defines the generators, transformers, or resources. That can be one of them or all of them in that customization, that YAML file. KFDev also defines the repo. So where you're going to pick up the manifest, right? So the repo reference say I have a manifest. I want to pick up the resource YAML file from which path, the directory here, right? And from which manifest. So you can use in the URL, which is the HTTPS from the GitHub, or you can use on your local branches, or even your local directory is all possible. And then you can provide a version here, right? And for certain platforms like AWS and GCP, there's also plugins. So under the applications, there's also plugins that you can specify for AWS or GCP. And AWS, they can use to create a cluster, and GCP can also specify some of the credentials and so on. And the manifest repo, as I say, it can be remote, archive, or a local directory. Right? And we'll look at one of the example, like the Argo. So this is the Argo's manifest that's saved under the manifest directory. So as I said, there's a base, right? Argo is the one of the application, and there's a base. Under the base, you have a define the cluster role, binding cluster role, and all deployments. And if you look into the customization YAML file, you will see there's defines all the resources that is going to be touched by the customized, and then the transformer of it is the image that you can say for the image, the name. I want to use the new name. I want to use the new tag. So when you touch one of the resources that the deployment that YAML file, you will change the the name in the tag to that image to whatever is specified here, right? And then there's also a generator. So here is the config map generator. You can say I want to generate a config map name with the workflow controller parameters, and then you can pass in what's the environment, the file to that, right? And there's some of the generator options and so on. And you can also define the vars that's going to be used in the for the KFDev in the Kctl to modify the resource definition in there. So let's say that transform of the image in the deployment here. There's you can see there's for a container there will be image, and so this because of that transformer is, and then this will be changed to whatever name you specify in there, right? Okay. So this is we talk about what the KFDev looks like. So let's look into the Kctl command, the flow, like how it's doing, right? So Kctl take a kfdev as the customer resource or the configuration file, and then you can run the command like apply, and we'll look into all the commands that Kctl has later in next slides. And you go to a Kctl controller, and the controller will be going to, look through all the application defined in the KFDev configuration, and then use customize to build, the final resource YAML file for each component. For example, here it has the metadata, kTip, pipelines, and so on. There's also the pipelines that you're also going to use in custom config to build the final resource YAML file, and then run with the Kubernetes apply function to apply all those resource YAML file on the clusters. So this is a very simple kind of the workflow of the Kubeflow command with the applied options, right? So if you go into Kubeflow, you can run a Kubeflow help. By the way, Kubeflow you can download from the Kubeflow repo for the latest release. But you can also build it yourself, and we'll talk about how to build it in the workshop, right? So you can run the Kubeflow help to look into all the commands, just like I was doing. Okay, I did not have that set up in there. Okay, so let me, yeah, so I have a set up the command here. So you can see there's a Kubeflow have a alpha, some of the alpha command is not, in the mainstream master string, and then there's apply, and then there's build, and there's a delete, and there's also a generate. So many commands we are using is the apply and build and delete, right? A build is basically building all the resources file for you with the Kubeflow configuration, but it's not really applied all the resource into the Kubeflow Kubernetes cluster. Apply is doing that. So you can run with the build first, followed by apply. And if you want to delete the Kubeflow deployment, you can run with Kubeflow with the delete subcommand and so on. Okay. And you always need to provide a Kubeflow configuration file as we are talking about. And then configuration URI can be remote or local. If you want to change the repos URI, then you can download a file from remote and update it and update it, right? And then later on, the what Kubeflow does is that it downloads the that manifests either from an archive, from a remote, or from your local directory, or whatever from branches, and then you will build a cache on your local disk. It's the directory where you actually applied or built the application, and then you loop through to all the application's customization configuration, and then we build or apply to generate the final resources file and so on. And then you run, the last thing is can run the spatial handling if the configuration contains plugin session. So if we look at here, it says this is one of the Kubeflow, right? We we provided. You can run with all the applications, and I point that into the remote, right, archive of the manifest repo. And then after this is applied or built, it is going to say the cache, the repo local cache is going to on your local cache and so on. So here you can see I will have all the repos actually downloaded to here by the Kubeflow, right? So you can see the go to if we have Argo, there's an Argo here, and you can go to see if there's Argo and with the base and base v3 and so on. And then what Kubeflow build is built this customized directory, and for all the applications that you put in the your Kubeflow configuration, it's going to just generate a customization file for you. So let's say if I want to see all the Kubeflow apps, so it's basically only generate just a customization.yaml file, right? And you can look into this customization.yaml file. It's basically just point back to the cache with that the Tectons, all the other manifests saved under that Tecton directory. And if you want to see what are all the resources are actually contained in with this customization file, you can actually do something that using the customized build to look into it. And you can see there's all the different resources. And for me, I'm actually doing Yeah, this will be just breaking all, you know, to break every resources in that generate output files. So if you look at one of the, let's see, one of it, let's say the deployment minial, for example, right? You just generate, this is a final output of the minial deployment, right? You replace all the whatever the variables or any config map changes that it's going to already replace by the customized by the Cave cutter, and you have the value from either from the key, either has the mount pass or something like that. Is all in the claim name, for example, this all replaced by whatever you already specified in your Cave depth configuration or in your you know, the overlays that you specify of those things, right? So okay, okay. So I think next one is the manifest report. It's maintained. Okay, I think I'm running late. I had to be get faster a little bit. So manifest maintain the manifest of Kubeflow's common applications. Have Argo, have central dashboard, or all these components. And there's also other applications. It's already show you that you can use customized view. And you, if you want to deploy to the Kubernetes cluster, you can run kube control kubectl apply -k. Okay, so the last thing I think is about the Kubeflow operator, and I think I had to pass maybe 5 or more minutes on that. So operator can help you deploy, monitor, and manage the life cycle of application deployed on Kubernetes in OpenShift cluster. So there's a native Kubernetes cluster, and there's an OpenShift container platform built on top of the native Kubernetes clusters. So that what this means that is the Kubeflow can run on both of these kind of clusters, and Kubeflow operator can also use to deploy on all these clusters. The Kubeflow operator we do is built on top of with the operator SDK, and operator SDK is under the operator framework. It's part of the Red Hat's open source project. I don't want to go detail on that. And then if you want to learn more about operator, you go to the link on the OpenShift container platforms documentation there. What we did with the Kubeflow operator is that we use the same apply functions that the kubectl command line is using. This is make it very consistent, and because of we using that, we can just using the custom resource, you know, the same kube depth configuration as the custom resource to deploy it, the Kubeflow, and so you know, we don't need to create our own custom resource info, right? However, for the delete function, we are kind of a little bit different from the kubectl delete command. Kubectl delete command today just remove the namespace, but we don't want that. So for the it's not perfect, right? So what we did is that we actually assign our own reference for each of the resources deployed to the Kubeflow. And when we delete, we only just delete the root, and we depends on the Kubernetes garbage collector to delete all the resources that are being trial and and grant trials for the custom resource, the kube depth document. I already show you that. So basically, you can see for operator is a Kubernetes cluster. There is comes into register, and then there's on the operator framework, there's a OLM, and there's also a catalog showing what operators that you have. And then you have a CRD, and you have a controller, and for each controller, you can look up to multiple of a custom resource. So basically, for a Kubeflow operator, right, you can deploy the on the same cluster, you can use it to deploy. One operator can deploy multiple of a Kubeflows on a different namespace with your own individual of a custom resource. Right. So we have a Kubeflow operator. We have this. These are our code structure. In the I can show you here under the deployed. This contains all the the operator SDK requirements to have a deployment, and then where is the image, the container image for this operator. Basically, in here is it's the the meat, right, of the Kubeflow operator, how to deploy the Kubeflow, and we in there we actually just using using the same cave cutter command and build on top of the same of the package of the Go package for the cave cutter. So the command we're running is cave cutter, right, and then provides the custom resource for it to run it. That's one. And there's also under the build is the Docker file, right? So this is what it means that if you are contributing to this project and you want to try the Kubeflow operator, you will need a Docker engine to run and to build your specific of the operator image. And to build that, we have in the make file we have a build operator that you can use to build, and then the push operator is you can just run the make build operator and make a push operator for that. Okay, and then the package controller inside this controller, we have a cave type controller, and this is also is based on what operator SDK require. We need to have a reconcile, we have a manager, and we have a controller, and we have a watcher to watch on what kind of resources is being changed. For now, we are looking on all the cave type custom resources, and also about all the resources that has been deployed to Kubeflow through these custom resources has been deleted, and then there will be lookup and the operator is going to redeploy it if it's that kind of resource is being deleted. What this means that is that this is what the operator is supposed to work to maintain the healthy of the your deployment. Yeah, so to install like Kubeflow through the Kubeflow operator, you can deploy the operator first and then creating the cave dev CR. And as I say, it's continued, right? And the Kubeflow operator, we also already deliver and push to the operator hub, right, the IO. So you can see here is one of the operator layer in the operator hub.io. And the command that you can deploy the operator, if you do in the manual way, you can do this way to and look into the operator markdown documents in the Kubeflow project. As I said today, we already registered this one, so it's able to be found in the OM console. Right? And so here you can see, I think I was just showing you like this is the one of the IKS cluster, and I actually install the OpenShift console on top of it. And then you go to the operators, and then you can look into the operator hub, and all the catalogs of the operator hubs are showing up here, and you can see the Kubeflow Kubeflow operator is here, and then you can click on it and you say I want to install it, and you can just do the install, which is just very you don't need to actually type anything. You just go here to try to do the installation and so on. Okay. That sounds simple and easy. So that basically is the way that you create a subscription to the operator. This is the second way. And the other way, if you want to run a command line, you can just doing the way I'm talking about here to download the configuration file, either for the Kubernetes or for the OpenShift. You need to download from the Open Data Hub IO. Okay, we have more topics, but I think I'm running out of time. We can do more later on that. And I guess that's it for me. Thank you, guys.
Thank you so much. So do we take the 1 hour break now?
Yes, this is the lunch, our lunch break.
Okay.
For some people, that might be a signal to go to sleep if they're in the middle of the night. But
Yes. Some people may want to have a siesta or their midnight time sleep. So we'll start in 1 hour.
we will start at 1 Pacific, 4 Eastern.